Hi, and welcome to the next lesson. In this lesson, we're going to go over two new clauses in Query SQL, and you can see their names in the fiddle title in the upper left of the screen, order by and offset. These are really useful and common SQL clauses that are used in many queries, especially order by. So let's start with that one. Often, when you're exploring a data set, you want to get some sense of the range of values in a column. What can be helpful is to sort the data by that column to quickly see the lowest and highest values. Let's sort this data set we have right now. Select star from users, which remember is just all the rows and all the columns. Let's sort this by column. Why don't we try credit balance so we can see the range of credit balances in our users. All I need to do is type order by credit balance. It's important that you put this in the right place. It comes after the from clause. Notice the semicolon ends the statement. Let's run this and see what we get. Okay, now you can see that the 4 rows are ordered by credit balance. It's an ascending order, meaning from the lowest to the highest credit balance. The lowest being negative $1.03, the highest being $100 for Sylvester. Ascending order is the default for order by. You can type it if you want to be explicit just by typing ASC, but it's not necessary. If you want to do descending order, the opposite, just type DESC at the end of the order by clause. Now you can see it's in the opposite order, with the highest credit balance, $100, being at the top of the list and the lowest at the bottom. Now, one thing we always want to think about whenever we're doing anything in SQL is what's going to happen if we have a null value in the field that we're using. So let's order by age, our one field in our data that has a null value. And you can see that by looking at the insert statement here. We have a null for Sylvester's age. Let's order by age and see how order by handles nulls. Okay, you can see that Sylvester with the null age is at the bottom of the list. That's how PostgreSQL handles nulls. It puts it above the highest non-null value in ascending order. So since we're in ascending order here, the highest non-null value is next to the last row, 45, and then null for Sylvester is at the end of the list. However, the SQL standard does not specify whether nulls should come at the beginning or end of an ascending ordered list. So you'll need to check with your specific database to see which option it chooses, but it's going to be one of those two. We can also sort by 2 fields. So let's sort by date created, order by date created, and then we just put a comma like in our select clause to to order by a second field. So we'll order by name as our second field. Let's see how this works. Notice that the data is first ordered by date created. So we have our 2 users, Bob and Sylvester, that have a date of 2/3 at the top of the list here, the bottom of the ascending order. So we're going from lowest to highest. And within that 2/3 date, we've got the rows ordered by name. So Bob coming before Sylvester in name order, alphabetical order. So you see that the second field in the order by only makes a difference if the rows are tied on the first field, which is date created. So that's how multi-column sorting works. Now we can actually control the ascending descending options on a per field basis. So for instance, you may want to do date created in descending, but leave name in ascending order. And that's as easy as typing DESC only after date created. So it's important to note that that option applies only to the field that is listed after. So if I type DESC after name, date created is still ascending, but then name is descending. So it switches Bob and Sylvester in the results. Now, one thing that's very interesting is you don't actually have to put what you order by in the select clause. Clauses are in many ways independent in SQL, and the select clause is really only there to tell the database what you want to see in the results. So if we want to just see name, we can do that. Even if we want to see a field that we're not ordering by, we can certainly do that as well. Let's bring in age. There we go. Perhaps we want to see name and age, and that's it. No problem. So the order by comes after the from, but it actually runs after the select runs. So to review the order, we do from users, then the select clause runs, showing name and age, and then the order by runs. So what it's ordering is actually the underlying data set. You might wonder if it runs after select, then how is it ordering by things that aren't in the select? Well, the select is really just about, displaying values. So order by can reference any value that's in the underlying data set. Okay, I think it's time to show you the next clause, and that's offset. So offset is really useful because sometimes you want to actually skip some results. You don't want to show them all. For instance, if we're showing name, age, and we're ordering by, let's say, just date created, and we'll go ahead and put date created in the select. Our first two users we know have the same date, so we just want to skip those. It's easy to do that. After the order by, we just type offset, and then the number of rows we want to skip, in this case 2. And there we go. So we've skipped the first 2 rows, and now we're seeing just Jim and Beth. So to review what's happening here, we've run the from clause first, then the select, then the order by, and after ordering, we then run the offset. It's important to know the offset comes at the end, after we've ordered the data. Another thing I'd like to show you in the order by is a little shortcut. I don't recommend using this for reasons I'll show you in a second, but you'll often see people using it. If you're just doing a quick query that you're going to throw away and not save, it's not a problem. So let's say I want to order by date created. It's in the select clause, and I don't want to have to retype it. As long as the field is in the select clause, I can just type in the number of the field, numbered from left to right. So in this case, date created is 3. So I can just type in order by 3. I'll get the same results. The reason this is dangerous, though, is because if later you add in a field up here, perhaps credit balance, it's now going to order by credit balance instead of date created. So in general, it's safer just to go ahead and type in date created, so you can be sure that's always going to give you the right results. The last thing I want to show you is what happens if I offset by 1 and order by date created. Notice that it's skipping one of the rows that's tied on the date 2-3. We've got 2 users that both came in on 2-3 and created their accounts. In the results, I'm only skipping Bob and showing Sylvester. And that does follow the order of the data as it was inserted into the table, as we can see in the schema SQL up here. However, what I want to emphasize is that the order of rows returned by SQL is not guaranteed to always be the same unless the order by clause expresses a unique combination of values. So for instance, if we don't have an order by clause, let's see if I comment this out with a couple of dashes. Well, we certainly can't be sure what we're going to see here. We're not ordering by anything, and we're just saying offset 1. So the record that it skips could be any of these 4 in the future. The database is basically free to reorder the rows as it's stored in the underlying table for efficiency reasons. So make sure, if it's important to you, that you get the same results, that you use an order by clause. But not only that, but if we're ordering by date created here, yes, in this case, we're getting Sylvester and skipping Bob. But because the order by clause does not represent a unique combination of values, so date created is not unique. We've got two users that have the same date. We'll need to add another field in the order by clause to make it unique. Easiest thing to do is to add in a field like ID that's guaranteed to be unique. So if we order by date created and ID and offset by 1, we're always going to be sure that Sylvester is going to show in this data. Okay, that's it for this lesson. We'll see you in the next one.